Evaluating expressions. I just changed the order of something in my thing I showed you on the first video. I just recorded the order of operations video, period. You haven't seen it yet, probably. If you're going through these in order, you haven't seen it yet. But I just recorded it, and at the very end of that section, it talked about some complicated expression evaluating. And I did those problems, and then I said, you know, this was pretty tough. I'm going to work some easier ones in the next video. So it occurred to me after I said that I have the flexibility to order these videos any way I want because I haven't published them yet. So even though I said that in the next video, I said, you know, stay tuned, we're going to work some easier expressions in the next video. That's not going to be the case. You're going to do those now, and then you'll see the order of operations video next. So it'll make sense when you get to that point. But okay, so that's the deal there. So I like being able to change things on the fly here a little bit. That's nice. Expressions, okay, terms added together. We talked about kind of the anatomy of the expression with the coefficient and all that. You know, 3 plus 4x is a simple expression. And there's really nothing we can do with that expression. We can't combine those terms because they're not like terms, okay? However, we can do what's called evaluate it if somebody tells us what x is, okay? X is some number, and if you're told what the number is, now you can do something with it. Because now it's 3 plus 4 times 5, okay? Now order of operations here. I multiply before I add. 3 plus 20. 23, okay? So we can evaluate expressions using these order of operations if we're told what these numbers are. Okay, let's look at this one. Okay, again, we'll use that same x equals 5. I can put the 5 in place of the 3 there. Inside my parentheses, I'm going to get an 8. And 4 times 8 is 32. Okay, pretty straightforward. Okay? If nobody told me what x was, the best thing I could do here is just distribute, right? I could still distribute and get a 4x plus 12. So that's a little different form, but that's it. Okay, and there's nothing wrong with that, but I couldn't boil it down to the value of 32 until somebody told me x equals 5, okay? That's all I could do. I could still go there. You know, now I could put the 5 in and say 4 times 5 plus 12. 20 plus 12 gives me the same 32. Okay, but without knowing x equals 5, there's not a whole lot I can do with that. Alright, let's take a look at another one. What if I have x and y together? What if I have 5x minus 3y? Somebody's going to be so kind as to tell me that x is 6 and y is 4. Well, I'm going to put the 6 in place of the x. I'm going to put the 4 in place of the y. I'm going to get 6 times 5 is 30 minus 12. And I'm going to get 30 minus 12 is what? 18? Okay. Oops. There we go. That makes a little more sense. You can actually see it. Okay with that one? How about this one? What about 3x plus 5y plus 2 all divided by 2x minus y? Okay, it's kind of messy looking. We need to be told what x and y are. We're going to be told x equals 6 and y equals 4, and we're going to plug that information in and evaluate this. Boil it down to just a number. I'm going to put 6 in for x. Let's not mix them up here. And 4 in for y. Okay, I've got a numerator, I've got a denominator. I'm going to do order of operations on each one. Okay, and since I'm publishing this video before the last one I just did, I got to talk a little bit about order of operations here. We're going to learn in the next video all the rules, but for right now the rules are going to be we multiply before we add. Okay, and that was the case on this last video. Okay, we multiplied the 4 and the 5, and then we added the 3. Okay, we multiplied the 5 and the 6, we multiplied the 3 and the 4, and then we did the subtraction. Okay, So we need to multiply before adding or subtracting. Okay, so that's what we're going to do here. 6 times 3 is 18. Multiply. Plus 5 times 4 is 20. Plus 2. That's up the top part of my fraction. 6 times 2 is 12 minus 4. Okay, so I knocked out all those multiplications first. Now I've just got a bunch of additions here. If you look at this, the whole numerator is going to add up to 40. 18 plus 20 plus 2 is going to be a 40. The denominator subtracts into an 8, and then I can finally do this division and get a nice 5 out of the deal. Okay? Alright, sweet. Sounds good. Alright, let's look at a few words, just in case you ever have to translate the written word into an equation or an expression. Let me pull this up. Translating to expressions. Let me move this up. These are some key words. Addition. Okay, obviously the word plus, we got that one. Sum, I mentioned that I think in the first video. That word sum means I'm adding. More than something. Increased by. All those buzzwords are going to mean add. Okay, subtraction. We got minus down pat. The difference between two things. If I'm taking the difference between 10 and 6, I'm subtracting 10 minus 6. Something less than something, or decreased by. Those are all words that mean subtraction. In multiplication, times, of course, is the no-brainer, the product of something. Twice is kind of a specialty. Twice means 2 times something, right? But we know it means times. Multiplied by, kind of hard to go wrong there. Division, quotient's the big one people forget, and ratio, those both mean divide. Okay, the other ones are pretty self-explanatory. So if we wanted to just kind of run through this example 3 here, translate the written word into the algebraic expression. The sum of a number and 7. Okay, well, when we say a number, that's our mystery. We'll call it x. Okay, sum means I'm adding. So I'm adding 2 things together. What am I adding? Some mystery number, call it x, a number, and 7 together. There we go. X plus 7. Okay, part B. 10 less than a number. 10 less than a number. Okay, sometimes these read a little backwards. 10 less than a number means I've got the number first and I'm going to remove 10 away from it, right? Because it's 10 less than the number. So I write the x first and then the minus 10. Commas are important in statements like this. Look at this one. Twice a number decreased by 6. So twice a number, 2x, but then I'm going to decrease it by 6. Take 6 away from it. Oh, you know what? I'm zoomed in still. My bad. I'm trying to make it all fit. Can't read it, I bet. Well, I'll read it. D. The product of 8 and a number. The product means times, right? So 8 times a number is just going to be 8x. The product of 8 and a number. And finally, E. 3 more than the quotient of a number and 11. So 3 more than something. So I got something and then plus 3 more. Okay? Well, what's the something? It's a quotient. That means a division problem, which I'll write that as a fraction. Division of what? Some mystery number, a number, and 11. So x divided by 11 and then plus 3. Okay? Basic translation. Sometimes we're going to have to translate the written word into the mathematical expression or equation. Okay? Alright, so this is this kind of will dovetail back into the order of operations video, which, like I said, I already recorded sitting here, but hopefully you're going to watch that video right now after this. So at the tail end of that video, I say I'm going to come back and do this stuff, but we've already done it. Alright, good deal.